warm-up 108, measures of variation, sketch a bell curve, and compute the z-score for 23 Michael Jordan. All right, I'll give you some time for that, and go. All right, check with the neighbor, see what they got, please. Should be done by now. Are we good? By now, like I said, we are experts at this. I'm just giving you this for extra practice because we're heading more into measures of variation, but now using with discrete distribution. Okay? So, give me a second. Bless you. Agenda for today, warm-up number 108. Discrete probability distribution. Tonight's home play, only 2 problems. You're like, only 2 problems. Let's go. Oh, yeah. Thank you, Mr. Q. You're welcome. I got you. Once again, your home play code is GP87X. It's only 2 problems. All right. So, with that said, get a Cornell note going, please. Today we're just going to add a couple more things to what we've been doing. I just want to make sure that we got enough practice on the binomial probability or binomial distribution, just to make sure that you understood the difference from what we're going to see today. Okay? Yes, Mr. Q. All right, so our objective for today can define and compute the discrete probability distribution. We've been in the middle of that. We covered the probabilities. We talked about variables, random variables. We've been working with discrete, and we also know the difference between discrete and continuous. Is that correct? Yes? All right. Just give me a heads up because we're going to start wrapping this up. You should know the difference between discrete and continuous. So if I was to ask you to make a poster and give you an example of each, you should know. Same thing with, you should know what discrete probability distribution is. Is that correct? All right. Tell your neighbor what goes where on that probability distribution, just to make sure they remember. All right. Good conversations. Yeah. Also, we talked about formulas once we add a discrete probability distribution to find the mean, the variance, and the standard deviation. Does everybody know each of the components? Where you get that from? Talk it over to your neighbor. Where do you get each of the components from? Where do we get each of those components from? All right, hint, hint, wink, wink. I just want to make sure that you know each of these in case that also goes on the poster, if I was to ask you for one. And then we know binomial distribution is because the outcomes are 2 at the end. From there, we gave you a formula that we've been working with. Yes, we know how to use that. Experts. We know what P is the success, Q is the failure, and once again, the success, it's usually in a percentage that is represented in decimal or fraction. Q is basically 1 minus P, and that's how we get Q. And we did something like this one. This is a little bit different, though. Copy this one on your paper, please, example Q. And yes, copy the whole thing. It's very similar to one we did, very similar. But you're going to see the difference today. A survey found that 1 out of 5 Americans say he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that at least 9 will have visited a doctor last month. Copy that. All right, here we go. Let me pause the music. Once again, it reads, a survey found that 1 out of 5 Americans say he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that at least 9 people will have visited the doctor last month. Okay, so before I get into that, write any utensils down, look up to the screen. Let's talk about at least versus at most. Explain to your neighbor what at least is versus at most. Talk to your neighbor. What does at least mean compared to at most? All right, looks like Caleb's got it. Very good. Lenny's got it. All right. So here we go. I'm going to give you some numbers to use in your talks. Let's say I give you numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How would you explain at least from here or at most from there? Talk to your neighbor. All right. Just for the sake of talk, I'm going to use the number 7. What does at least 7 mean versus at most 7? Talk to your neighbor. What does at least 7 versus at most? All right, looks like Chelsea's got it. Very good, Chelsea. What does at least mean, Diego? So the minimum has to be 7. So I don't have to use any of these, but I need to use at least 7 and what? 8, 9, and 10. That is correct. So at least the minimum is 7, so it's 7, 8, 9, and 10. Okay. How about at most? Pass it to someone. What does at most mean? Jaden, Wilson. So 7 is max. So that means you need to use everything below 7. So 1, 2, 3, 4, 5, 6, and 7. Hands if you agree with that. That's pretty clear, yes? All right. With that said, let's go to the problem at hand. Writing utensils down, look up to the screen. It reads, well, let's get started together. Over here on the side, write N. Write X. Write P. And write Q. All right? So, everybody, what's N? 10, okay. For right now, I'm going to skip X. Tell your neighbor what P is. 1 out of 5, so it's 1/5. Oh, it's not going to be 5. Looks like a 6. 1/5. And what is Q, everyone? 4/5, because it's 1 minus 1/5 is 4/5, okay? Let's talk about X. Look up, please. This one says, if 10 people are selected, find the probability that yesterday and the day before we did exactly so many, right? But today it says what? At least. Tell your neighbor what that means. What does that mean? Jaden, pass him one. Fernando. Therefore, I'm going to use 9n, which is 10. That is correct. So my x is 9 and 10. So, look up to the screen. Do you know how to do this portion with a formula? But then we need to do it again with what? 10. So what do we do at the end, Mr. Q? We do P of 9 plus P of 10, and that's going to give us the probability of at least 9 that visited the doctor. Does that make sense? All right, so therefore, let's get our formula. P blank equals blank factorial blank minus blank factorial times blank blank exponent times blank to the blank minus blank exponents. So let me move this down a little bit. So my first x is going to be what? Start with what? 9. So 9 goes here. 9, 9, 9, and 9. N is 10. 10, 10. What else? Right here. And 10. P is 1/5. And Q is 4/5. All right. So, simplify. Let's do P of 9 equals 10 factorial over 1 factorial, 9 factorial, times 1/5 to the 9th power, times 4/5. Do I need to put a little 1 on the exponent? No, right? Because 10 minus 9 is 1. Okay, I'll leave it like that. P9 of P of 9 is 10 times 9 factorial over 9 factorial, and I'm going to put a 1 for the 1 factorial, times 1/5 to the 9th times 4/5. So, to save space, cancel these, or that becomes a giant 1. So this becomes 10 times 1/5 to the 9th power times 4/5. Calculators calculate. What does that become? Bless you. Move this down here. All right, who's got it? Now I'm going to pass someone. .00. How many zeros? All right, so 0.0000. How many zeros? 4? 5? 09? 409? 6. All right. So that is for this one. So I'm going to write it here. 0.000004096. We need to add that to what? P of what? 10. So we need to do all this again, but for P of 10. So now it's 10 here, 10 here, 10 here, 10 here. N is 10, 10, 10, 1/5, 4/5. So just to go a little bit faster, look up P of 10. What is 10 factorial over 10 factorial? That's a 1, right? Question, what is 10 minus 10? What is 0 factorial? Remind your neighbor. It's 1, right? So this whole thing is 1 times 1/5 to the 10th power. And 10 minus 10 is 0, so any number to the 0 power is 1. That is correct. So 1 times 1 times 1/5 to the 10th. What is 1/5 to the 10th? Calculators calculate. So let me start with 0 point, how many zeros? 8. So point, 1, 2, 3, 4, 5, 6, 7, 8. 1, 0, 2, 4. So that was P of 10. So now that we have P of 9 and P of 10, add those together, and our total is what is it? Point 1, 2, 3, 4, 5 zeros. 4, 0, 9, 7, 0, 2, 4. And that is the probability of what? Of at least 9 people visiting the doctor last month. The what? Look. Do you follow? Come on, jaded. It's only decimals. Right? You don't follow? All right. So what's the difference from what we did before? Before we only used one number because it said exactly that number, yes? But now today we have at least 9, which means that we need to use 9 and 10. 9 is the minimum, okay? So, and then what do we do at the end with both of those probabilities? We add them, and that's our total probability. From 1 to 5, I'll come through with this, okay? Now check this out. Look up to the screen. Don't copy it. It reads, a survey from Teenage Research Unlimited, Northbrook, Illinois, found that 30% of teenagers, consumers, or teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at most 3 of them will be part-time, will have part-time jobs. So, don't copy this. However, share with your neighbor what N is, what is X, what is P, and what is Q. Don't copy this. Just share with your neighbor what we're going to use for those. All right, get us started. Peyton, N. 5, that is correct. Everybody got that? Yes? All right. What is P? Pass someone. Peyton. Mia. Victoria. Yeah. 0.3 or 0.30. How about Q? Pass someone. Chelsea. 0.7 or 0.70. And once again, we got P, we got 1 minus P, 1 minus 0.30 is 0.7, that's how we get Q. And last but not least, what is or what are X? Pass someone. Chelsea. Peyton. 3. 1, 2, and 3, that is correct. But for the purpose of probability, look up to the screen, you need to include 0. Because there should be a probability of 0 teenagers working part-time. We good? So we're not going to do this one, but do you know what to do from here? What do we do? P of 0 plus P of 1 plus P of 2, and at the end, P of 3, which means you needed to find all of these. Yeah? All right, from 1 to 5, I'll come to you with that. All right, so home plate for tonight. I'll stop the video lesson here. You already have the code. Let me stop this here. Enjoy. Bye.